All right, last prove it question that we have is tangent of x is equal to 1 minus cosine 2x over sine of 2x. So we make decisions when we do these prove it type questions based off of like what we need to find, what we need to do, so on and so forth. Now, I just want us to keep in the back of the mind, this is going to seem a little bit obvious, but that's okay. Tangent of x is equal to sine of x over cosine of x. So I'm saying that because this top piece needs to have a sine x in it. So that's going to influence the decisions that I make. So that being said, I am going to say, okay, 1 minus cosine of 2x. I have a couple of options for cosine of 2x. I have 3 options for cosine of 2x. Okay, I have the first, cosine squared minus sine squared. I have 2 cosine squared of a minus 1. Then I have 1 minus 2 sine squared of a. The problem with the first two for this particular problem is that they have these cosines in it. I only want sines on top. So what I'm going to do is I'm going to say cosine of 2x is equal to this 1 minus 2 sine squared. And that's because I want it to equal tangent, and tangent has sines on the top. We don't have many choices with the bottom, so that's why I'm spending a little bit of time explaining my top choice. So I'm changing this cosine of 2x to 1 minus 2 sine squared of x. All right, now, watch what I did. I put this in parentheses, and that's telling me to distribute this negative throughout. So don't just like throw it in there. Make sure you put that entire expression in parentheses because you're going to distribute this minus sign throughout my entire top pieces expression. The bottom, I only have one option. It's going to be 2 sine x cosine x. That's it. That's all I got. So, and I've got to change it because this is a sine of 2x and we just have regular x. All right, so on the top, I'm going to distribute this through. So this is going to look like 1 minus 1. So that's exciting. 1 minus 1 plus 2 sine squared of x over 2 sine of x cosine of x. All right, it gets better. 1 minus 1 cancels. So then I have 2 sine squared of x over 2 sine x cosine x. We're getting very close. The 2's are going to go away. 2 and 2 are going to go away. And then I have a sine squared and I have a sine on the bottom. The sine is being multiplied with the cosine, so I can break it apart. So sine squared over sine is going to cancel out the sine on the bottom and leave me with a sine on top. So I'm going to just be left with sine of x over cosine of x. And then that equals tangent of x. Love it. It looks fantastic. Very exciting. And that's it. That's how you would prove that question. Try it on your own. And once again, there's really nothing we can do with this left side, which is why I'm choosing the right. You can choose either side. It really doesn't matter. But usually one side will kind of like land you in no man's land. You'll be kind of it won't be very useful very quickly. All right, and then last example that I have is the simplified 2 tangent 15, 1 minus tangent squared of 15 degrees. This looks pretty intimidating. It's not. The idea behind this is that you recognize that tangent of 2a is equal to 2 tangent a over 1 minus tangent squared of a. So this has the same form as the tangent of 2a formula. So if I look at my expression that they give me, I can kind of see that they're saying that 15 degrees is equal to a. That's what they're getting at. So if they want me to simplify this, I can simplify this by saying, well, this is just the same thing as tangent of 2a. This is just the same thing as tangent of 2 times 15, or tangent of 30 degrees. Just taking it, kind of working in reverse, backwards, in order to find what that double angle looks like when they give you what A is.